Okay, section 6 of chapter 2 is dealing with proofs. Again, last section we dealt with algebra proofs, solving a problem in algebra and using algebraic reasoning like adding, subtracting, multiplying, dividing to prove how you were able to do something. We're taking those same steps or the same way that you solve those problems and we're applying them today in geometry proofs. A proof is a verbal explanation showing the solving of a problem. We usually use a T-chart or a two-column proof. And so what we're going to do is we're going to draw our two columns. One of those is going to be steps. The other is going to be reasons. We're going to go through our steps and explain why or how we were able to do these. Now, each proof is given some information right away. Maybe it's given in a diagram or maybe it's said out loud. There's also a direction to go. You're always told to prove something. The last thing that we should be proving here is that angle EBA is equal to angle DBC. So we're going to write down at the bottom of our proof, angle EBA is equal to angle DBC. And at that point, we should be done. And you always start by writing what's given. And they gave us that angle 1 is equal to angle 3. And this is how you start. This is where you end up. And what you should slowly learn is this is like a puzzle. They give you one piece. You have to kind of figure out some other pieces using different geometry ideas. And then when you're done, you should have some type of a puzzle figured out. Now, geometry proofs are very, very abstract. They're not always straightforward. Some of them are, some of them aren't. This one that we proved together is a proof that you're going to see a few times over. What I want to show you right away is that angle 1 and angle 3 are congruent. That was given to us. And so what we're going to do is we're going to use that information to eventually solve or prove that EBA is equal to angle DBC. The way we want to start off first is by adding a couple angles together. The first thing we're going to do is we're going to say that angle 3 plus angle 2 equals angle EBA. And all I did there, let me erase some of this so that you can see what I did. All I did was say that angle EBA is made up of this angle plus this angle. And there's a geometric property that we learned in chapter 1 called the angle addition property that says if you add two small angles together, you'll get a bigger angle, like angle 2 plus angle 3 gives us angle EBA. Now what they told me at the very beginning of my problem was that angle 1 and angle 3 are congruent. I'm going to use that information now, and instead of writing angle 3, I'm going to write the same step that I just did, but I'm going to substitute angle 1 for angle 3. You might say, how'd you do that? Or how can you do that? Because here I've got angle 3. Up here I'm told that angle 1 and angle 3 are the same thing. This is like saying that I'm going to give you, instead of giving you 5 $1 bills, I'm going to give you a $5 bill. It's the same value. They told me angle 1 and angle 3 are the same. And so instead of writing angle 3, I'm going to write angle 1 because I can substitute it in. Angle 1 plus angle 2 equals angle EBA. And again, what allows me to do that is just to substitute, or the substitution property. Again, here I have a problem that says angle 3 plus angle 2 equals angle EBA. I'm taking out angle 3 and putting in or substituting in angle 1 because they equal the same thing. That the substitution property allows me to do that. Again, it's like you owe me $5. But instead of paying me a $5 bill, you're paying me 5 ones. It's still the same. It just looks different. Here, instead of writing angle 3, we're going to write angle 1. The next thing I'm going to write is that angle 1 plus angle 2 also equals angle DBC. And if I look over at my diagram, I can see that angle 1 plus angle 2 equals angle DBC. And the same property that I used up here, I'm going to use again, called the angle addition postulate. Just adding two small angles together to get a bigger angle. But now if I look, I have angle 1 plus angle 2 equals EBA. Angle 1 plus angle 2 equals DBC. Now I'm going to use the transitive property to cross these off and write my new equality statement, just like the law of syllogism. I've got two statements. I cross off what's used twice, and I write my new statement. Angle EBA equals angle DBC. And again, I use the transitive property. Well, if I look, that's exactly what I wanted to prove from the start. So I'm done. Now again, you might be saying, Mr. Gentry, if I was doing this by myself, I would have no idea how to go from angle 1 and angle 3 being the same all the way down to that. You're right. Most kids have a hard time with geometry proofs because they don't know what steps to start taking. They don't have a clear direction in their mind. So what you have to do is you have to basically just kind of say, all right, I'm going to try, that's the key point. You can't just say, oh, I don't get it, I'm not going to do it. You have to try and say, okay, they gave me angle 1 and angle 3 as being congruent. I can see that angle 2 is kind of out here in limbo. So if I can use angle 2 and some of the properties that I know, I could substitute angle 1 and angle 3 for angle 2. And that's exactly what we did. We said that angle 2 plus angle 3. And then we said angle 1 plus angle 2. Well, angle 2 occurs twice, so we just kind of substitute it out. And then what we have is we have the transitive property, saying that EBA equals DBC. And again, I know that this is difficult. I know that there's a lot involved here, but this is a geometry proof. You have to be able to take these ideas that we've learned so far in geometry, and you have to apply them. Let's look at some more problems, or some more properties. Here are some congruency theorems you can use with line segments or angles when writing a proof. Have you ever seen these before? Here we have the reflexive property, the symmetric property, the transitive property, the reflexive property, the symmetric property, the transitive property. I told you my pen is screwing up. Told you you'd be seeing these again. Now again, you're going to see them more and more so that if you didn't learn them last section, you'll have more opportunities to learn them before it's just taken for granted that you understand them. Again, you're going to see them so much, I'm just going to take it for granted that you know what they are now. We're going to name the properties illustrated here. If I told you that R is congruent to T and that T is congruent to P, what allows you to say that R is congruent to P? You're taking what R is congruent to, what P is congruent to, and saying R is congruent to P. Well, if I look, T is being used both. So ultimately what I did was I crossed those out and I wrote my new statement that R was congruent to P. Well, if I look back, that is the transitive property. A is congruent to B, B is congruent to C. They crossed off B and said A is congruent to C. So I can say that is the transitive property. And I don't need to say it's the transitive property of angles. I don't have to say it's the transitive property of line segments. The transitive property is the transitive property. You can apply it to angles, to line segments, to numbers. You can apply it anywhere. Let's look at number 2. They tell me that NK is congruent to BD. Then they flip the statement around and say BD is congruent to NK. It's the exact same statement written in an opposite direction. Almost like it's symmetrical, meaning it's the symmetric property. They took a statement like AB being congruent to CD, then they flipped it around and said the exact same thing backwards. Again, almost like it's a reflection. CD, AB, congruent. Almost like a reflection. The next thing, CD is congruent to CD. I can say anything in the world is congruent to itself. That's called the reflexive property. The reflexive property. Something is just being compared to itself. Then I'm told that angle Q is congruent to angle V, and angle V is congruent to angle Q. Again, very, very similar to what was just said, except it's been flipped around. Almost like it's a mirror image. That is the symmetric property. Those 3 properties, the transitive, symmetric, and reflexive, you have to know. They will make your life easier or they will make your life significantly harder based on whether or not you remember them. So, let's kind of review. Geometry, proofs. Taking geometry ideas and using them to prove a problem. What allows you to do this? Well, it was the addition property of the angle addition property. What allows you to say this? Oh, it was the segment addition property. Okay. Something that it takes more practice. We're going to spend a lot of time practicing these proofs on tonight's homework. So let's go ahead and take a look at it.